When installing a temporary transformer, proper grounding is crucial for safety and performance. The grounding electrode should be installed as close as possible to the transformer, ideally within a few feet. This minimizes the path for fault current to reach ground. A single copper-clad steel ground rod, at least 8 feet long, should be driven into the earth. The rod should be at least 5/8 inches in diameter and galvanized or coated to prevent corrosion. In areas like Orlando, Florida, where the soil may be sandy or difficult to penetrate, consider using a chemical grounding rod enhancement solution to improve grounding efficiency. Connect the ground rod to the transformer using a big copper conductor that is at least number 6 American wire gauge. Run the ground conductor from the transformer to the grounding electrode using the shortest, most direct path possible. Keeping the grounding electrode near the transformer offers the best grounding protection, minimizing impedance between the two. Running the grounding electrode with the main feed is acceptable if the ground conductor is close to the feeder cables and impedance is low. However, this may increase inductive coupling, creating ground loops and potential electrical hazards. Ensure the ground rod is driven into undisturbed soil, away from underground utilities or other structures. If the ground rod does not achieve a low resistance to ground, additional measures may be needed, such as installing multiple ground rods or using a ground loop electrode. Consult with a qualified electrician for proper installation and testing to guarantee a safe and effective grounding system. The National Electrical Code, or NEC, provides guidelines for grounding and bonding to ensure electrical safety. Article 250 covers grounding and bonding requirements for electrical systems. Section 250.50 discusses grounding electrode systems, specifying the types of grounding electrodes that can be used, such as ground rods, ground plates, and concrete-encased electrodes. Section 250.52 details the requirements for specific grounding electrodes, including size and installation depth. Section 250.53 covers the installation of grounding electrodes, including the requirement for a bonding jumper to connect multiple electrodes. Section 250.66 specifies the size of the grounding electrode conductor used to connect the grounding electrode to the neutral bus in the service equipment. Proper sizing of this conductor is crucial for safely carrying fault current. Grounding electrode conductor should be copper, and the size is based on the size of the service entrance conductors. For example, if the service entrance conductors are number 2 American wire gauge copper, the grounding electrode conductor should be at least number 8 American wire gauge copper. If the service entrance conductors are 3/0 American wire gauge copper, the grounding electrode conductor should be at least number 6 American wire gauge copper. The grounding electrode conductor must be securely connected to the grounding electrode using approved methods such as exothermic welding or listed connectors. The connection should be accessible for inspection and testing. The grounding electrode system should have a resistance to ground of 25 ohms or less. If a single ground rod does not achieve this resistance, additional ground rods should be installed and bonded together. The ground rods should be spaced at least 6 feet apart. The NEC also requires that the grounding electrode system be bonded to the metal water pipe in the building, if available. A bonding jumper is used to connect the grounding electrode system to the water pipe. The size of the bonding jumper is based on the size of the service entrance conductors. For example, if the service entrance conductors are number 2 American wire gauge copper, the bonding jumper should be at least number 8 American wire gauge copper. If the service entrance conductors are 3/0 American wire gauge copper, the bonding jumper should be at least number 6 American wire gauge copper. The bonding jumper must be connected to the water pipe within 5 feet of the point where the water pipe enters the building. The bonding jumper should be protected from physical damage. In addition to the grounding electrode system, the NEC also requires equipment grounding. Equipment grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device to trip and clear the fault. Equipment grounding conductors should be installed with the circuit conductors in the same raceway or cable. The size of the equipment grounding conductor is based on the size of the overcurrent protective device protecting the circuit. For example, If the overcurrent protective device is rated at 20 amps, the equipment grounding conductor should be at least number 12 American wire gauge copper. If the overcurrent protective device is rated at 60 amps, the equipment grounding conductor should be at least number 10 American wire gauge copper. Equipment grounding conductors should be connected to the metal enclosures of electrical equipment, such as panel boards, junction boxes, and motor housings. The connections should be made using approved methods, such as grounding screws or listed connectors. Ground fault circuit interrupters, or GFCIs, are required in certain locations to protect against electrical shock. GFCIs detect ground faults and trip the circuit, interrupting the flow of electricity. GFCIs are typically required in wet locations, such as bathrooms, kitchens, and outdoor areas. They are also required in construction sites and other locations where electrical hazards are present. When installing a temporary transformer, it is important to consider the voltage drop in the conductors. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the constant for the conductor material, I is the current in amps, D is the distance in feet, and circular mils is the cross-sectional area of the conductor. To minimize voltage drop, use larger conductors or shorten the length of the circuit. When installing a temporary transformer, it is also important to consider the overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. The size of the overcurrent protection device should be based on the ampacity of the conductors and the rating of the equipment being protected. The NEC provides guidelines for selecting the appropriate overcurrent protection device. Circuit breakers should be installed in readily accessible locations and should be clearly labeled to indicate the circuits they protect. Fuses should be of the correct type and size for the circuit being protected. When installing a temporary transformer, it is also important to consider the working space around the equipment. The NEC requires that there be adequate working space around electrical equipment to allow for safe operation and maintenance. The working space should be clear of obstructions and should be large enough to allow workers to perform their tasks safely. The NEC specifies the minimum dimensions for working space based on the voltage of the equipment and the location of the equipment. For example, for equipment operating at 600 volts or less, the working space should be at least 3 feet deep, 3 feet wide, and 6.5 feet high. When installing a temporary transformer, it is also important to consider the labeling requirements. The NEC requires that electrical equipment be properly labeled to indicate its voltage, amperage, and other important information. The label should be permanently fixed to the equipment and should be legible. Panel boards should be labeled to indicate the circuits they serve. Disconnect switches should be labeled to indicate the equipment they disconnect. Transformers should be labeled to indicate their kVA rating, voltage, and impedance. When installing a temporary transformer, it is also important to consider the requirements for flexible cords and cables. Flexible cords and cables are often used to connect temporary equipment to the power source. The NEC specifies the types of flexible cords and cables that can be used for different applications. Flexible cords and cables should be protected from physical damage and should not be run through walls, ceilings, or floors. They should also be properly supported to prevent strain on the connections. When installing a temporary transformer, it is also important to consider the requirements for ground fault protection of equipment. Ground fault protection of equipment, or GFP, is required for certain types of equipment to protect against ground faults. GFP detects ground faults and trips the circuit, interrupting the flow of electricity. GFP is typically required for equipment operating at 480 volts or higher. It is also required for certain types of equipment, such as electric heaters and snow melting equipment. When installing a temporary transformer, It is also important to consider the requirements for surge protection. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning, utility switching, or other events. SPD should be installed at the service entrance and at sensitive equipment. The NEC provides guidelines for selecting and installing SPD. When installing a temporary transformer, it is also important to consider the requirements for arc flash hazard analysis. Arc flash is a dangerous electrical hazard that can occur when there is a fault in an electrical circuit. An arc flash can cause severe burns, blindness, and even death. An arc flash hazard analysis should be performed to determine the potential arc flash hazard and to select appropriate personal protective equipment, or PPE. The NEC provides guidelines for performing an arc flash hazard analysis. When installing a temporary transformer, it is important to follow all applicable codes and standards to ensure a safe and reliable installation. Consult with a qualified electrician to ensure that the installation meets all requirements. Proper grounding is essential for electrical safety. It provides a path for fault current to return to the source, allowing the overcurrent protective device to trip and clear the fault. A properly grounded electrical system reduces the risk of electrical shock, fire, and equipment damage. Grounding ensures that metal parts of electrical equipment are at the same potential as the earth, preventing dangerous voltage differences. It also helps to stabilize voltage levels in the electrical system, improving the performance of equipment. The NEC requires that all electrical systems be properly grounded. The grounding electrode system should be installed in accordance with the NEC requirements. The grounding electrode conductor should be properly sized and connected to the grounding electrode. Equipment grounding conductors should be installed with the circuit conductors. Ground fault circuit interrupters should be installed in required locations. By following these guidelines, you can ensure a safe and effective grounding system.